Alright, so in the notes for 7.2, we're going to be looking specifically at triangles. The notes for 7.1 talked about all the different kinds of polygons, but today's notes are just about triangles. Two important words for you to remember the definitions of here. So an isosceles triangle has two sides that are the same, and in an equilateral triangle, all three sides are the same. The isosceles triangle theorem says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And so we're going to be solving some problems today using the isosceles triangle theorem. I want to start by talking about example number 1. Look at the picture. These two sides are marked as being congruent, which means that this is an isosceles triangle. And the theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So you see how in the picture for this one, this angle is marked as 3x, this angle was marked as 1x, and then this angle over here didn't have anything on it at all. This one was x, so you could write down that this one was also x. So to solve for x in the picture, which is the first thing I have to do, I did 3x plus 1x plus another 1x, and so this x right here was this x right here. You have to add that into the picture. They're always going to equal 180 because all of these are triangles. So for today, this is always going to be 180 because it's all triangles today in the solving. So anytime it's a triangle, it's going to be equal to 180. I combine like terms, solve for x. Now on this one, they want me to figure out how big angle t is. So angle t is this one up here on the top. So to get my answer to the question, I'm going to plug in the number I got for x in for the x right here, and so I'd get the measure of angle t is equal to 108 degrees. So everyone, in these three examples that we're going to do down here, notice how I've already pre-drawn some of the things on them. Everything in red is something that you would have to notice about the picture. So this is an isosceles triangle because these two sides are marked as being congruent. Notice how I drew the two arrows. I would recommend that you do that too. These two angles aren't the same, but the two angles that are across from the congruent sides are the same. So that's why I know that this angle right here, angle P, is also going to be 3x plus 3, and I can use that information to set up the equation. And so this is what your equation would look like for this one. 5x minus 2, this angle, plus 3x plus 3, this angle, plus the other 3x plus 3, because the angles opposite congruent sides are congruent, equals, and today it's always going to equal 180 because they're all triangles. So let's see, now we're going to combine like terms on the left-hand side of the equation. So 5, 6, 7, 8, 9, 10. So you'll get 11x plus 4 is equal to 180. Just be careful when you're combining like terms there. Then you'll need to minus the 4 from both sides. So you'll get 11x is equal to 176. And then to finish solving for this one, remember you're trying to get the x all by itself. So you're going to divide both sides by 11. And for this one, you're going to get x is equal to 16. You have to be careful, though, because this is not the answer to the question. They want us to figure out the measure of angle P. So once I get x equals 16, I'm going to come over here. The measure of angle P is equal to 3 times you plug in the 16 that you got for the x plus 3. And so what's that going to be? 48 plus 3. So the measure of angle P will be equal to 50 and 51 degrees. And so you want to be careful because the directions to the question will tell you what you're solving for, and that will determine when you solve to get your x answer where you have to plug it in to find the answer to the question. Question 3 is a little bit simpler because it doesn't have as many x's in it. Remember, it's an isosceles triangle because these two sides are the same. And so the angles across from those sides are equal, so that's why the 46 is drawn in here. But notice that you still don't know how big this angle is, so I'm going to go ahead and call that x. For this one, x plus 46 plus 46 has to equal 180 degrees. And so then you can go through and you can solve the equation from there by combining like terms. And then you'll subtract the 92 from both sides, so 182 take away, or 180 take away 92 gives you 88. And then they want us to find the measure of angle A. So for this one, angle A was already just x, so there's no work you need to do for this one. You just say that the measure of angle A is equal to 88 degrees. So for example number 4, it's an isosceles triangle. These two angles are marked. These two sides are being marked as being congruent. which means the angles across from them are also equal to each other. So you'll use that information to figure out that this one's 2x plus 2, which means that this one's 2x plus 2, and then from there you can create your equation, which for this one will be the 3x plus 1 plus the 2x plus 2 plus the other 2x plus 2 is equal to 180 degrees. And then you can go through and you can solve from there. So start by combining like terms. So that's going to give you 7x plus 5 is equal to 180. You'll minus the 5 from both sides. So you'll get 7x is equal to 175. And then to finish this one, you're going to divide both sides by 7. So you'll get x is equal to 25. But you want to be careful because remember, that's not the answer to the question. For this one, we were being asked to find the measure of angle R, which is this one right here. So the measure of angle R is going to be equal to 3 times 25 plus 1. You take whatever answer you got for x and you plug it into whichever angle you're being asked to find. The measure of angle R is equal to 75 plus 1. So your answer for this one would be the measure of angle R is equal to 76 degrees. Final answer. Okay, so the isosceles triangle theorem said that if you had two sides of a triangle congruent, then the two angles opposite those two congruent sides were also congruent. The equilateral triangle theorem says if all three sides of a triangle are equal, then all three of its angles are equal. And the opposite of that is also true. So, if all three angles of a triangle are equal to each other, then these sides would be equal to each other because they are opposite congruent angles of the triangle. So you can solve for x by setting these two sides of the triangle equal to each other. You would, so 5x minus 12 would equal 3x minus 4. You'd go through and solve for x. And then you look and you figure out which one they're wanting you to solve for. Because these are equilateral triangles, it actually doesn't matter which of the sides you plug it into. So what this one has written down is it says DE is the same as DF and EF. They're all equal to each other. So instead of plugging it in for DE, since that one didn't have a label, I went ahead and I plugged it in for, let's see, 3x minus 4. I plugged it in for EF, and then I solved and I got the answer to the question. So that side of the triangle over here would be 8. We'll go through and we'll do the example for number 6 together. So for example number 6, the two sides that are marked for you are opposite congruent angles, which means in an equilateral triangle that those sides are going to be congruent to each other. So I'll take this side, 10x plus 3, and I'll set it equal to this side, 3x plus 24. Because in an equilateral triangle, all of the sides are equal to each other. So I'll start by going through and solving for x. I'll minus the 3x from both sides. And then I'll minus the 3 from both sides. And so for this one, I'll get x is equal to 3, which is not the answer to the question because they want me to find the length from k to l. So on this one, KL is labeled. And so I'll say that the distance for k to l, or the length from k to l, is equal to 3 times, plug in the 3 that I just got for x, plus 24, and then I'll just simplify from there. So the length from k to l is equal to 9 plus 24, so the length from k to l is equal to 33. Remember, it's important that when you solve for x, you always look back up to the directions to the question to see which segment they're having you solve for. In an equilateral triangle, it doesn't make sense, but in a different shape, it matters which one you plug it in for.